Hi everyone, I'm going to go over the Unit 3 test review, the free response questions. I'm going to try and do all three in one video. So I do have them all written out. I'm just going to explain them. So hopefully you've tried them and you're not using this to copy. I'm pretty sure these are the exact same questions, just spaced out, okay? So this first one, they give you A and B, and they say, will F be continuous? So your answer is yes or no, okay, at x equals 2. So we plug in 2 for x, and you plug in -3 for A and 4 for B. And what we need to figure out is the limit from the left, does it equal the limit from the right? And you can see when you do the math, the limit from the left is -2, and the limit from the right is also -2. So yes, f is continuous at at x equals 2. Yep, but the y value was -2 because the limit is equal to the actual value. So if those were A and B, would the two pieces meet together? Yes or no? Okay. If A equals -3 and B equals 4, will F be differentiable? Now, differentiable means their derivatives are equal to each other. So the first thing we have to do is find the derivative of each one. And, oh, no, before we find the derivative, we have to plug in A and B. I was wondering, where'd that -3 come from? Well, there it is, it's right there. So we plug in the A's and the B's to make a function of x, and then we have f prime. So you take the derivative of each piece. 2 times -3 is -6x, plus 4, the derivative of 4x, and the derivative of 2 is 0. Derivative of -3x is -3. Derivative of 4 is 0. So here's our derivative function. In order for this piecewise function to be differentiable, the derivatives have to equal each other from the left and from the right when x is 2. So what we're going to do is we're going to plug in 2 into the derivative. And when you plug it into the top piece, we get a derivative of -8, but the bottom piece has a derivative of -3. So actually, these are not differentiable at 2 because the derivative from the left does not equal the derivative from the right. And if we didn't do this notation in class, it's okay. You don't have to have that notation. Your work is shown here, and that's fine. But just know that it does say all this means is the derivative from the left does not equal the derivative from the right. All right. So if it was continuous but not differentiable, what we want to figure out is, well, what would A and B be? What would make it continuous and differentiable if x equals 2? I hope this isn't blurry. I don't know why, but today that almost seems extra blurry. There, I'm adjusting. Okay, so I highly recommend you labeling your work just like me. What happens is I see students who label their work just like me and they get the right answer. And when people don't label their work, the grader has to find your work, and the grader wants to easily find their work. So labels are appreciated. All right, so we have a continuous function. We don't know what A's and B's are. That's what we're trying to find. So to make f of x continuous, we would set the top piece equal to the bottom piece. Where'd the 2's come from? Well, we're talking about x equals 2, right? So we plug in 2 for all the x's. We have lots of A's and B's and 2's, and it would be a good idea to just clean this up as much as possible. So what we did here is I moved the A's to this side by subtracting, and then I moved the B's to the left by subtracting, and then I just moved the constant over to the right. So we have 2a plus b equals -2. Now what would make it differentiable? What would make this function differentiable if the derivative from the left equals the derivative from the right? So again, take the derivative with respect to x first. Don't plug in the 2 yet. So we had ax squared, but the 2 came down in front. 2ax plus, wasn't it bx? It was bx, and now it's b, equals the derivative of ax plus b is just a. After we set the derivatives equal, that's what we want to be true. We plug in x as 2, and we get 4a. All right, you guys, there's a couple different ways to do this. probably you solved for b here by subtracting the 4a. And you could say b, I'll show you a different way that's on this paper. B equals negative 3a, right? If you subtract 4a from both sides. And then you could take this and plug it in here. 2a minus 3a equals negative 2. And that would give us negative a equals negative 2, which means a equals positive 2. Yeah? And if a is positive 2, you plug it back in here, and we would get b equals negative 6. So that's using substitution. If you use these two equations here, you see here how I used elimination. It's been a while since you've done that, but you eliminate the b's, add the a's down, and we get the same answer. So either way, don't do both ways. Okay, we've done lots of practice on this, so you should be ready for a question like that on the test. Ready for question 2? Question 2, consider this function and this function, and we're going to answer the following question. So, just a review of derivatives, tangent lines, normal lines. Here we go. Are you ready? So, again, I have it all typed out or written out, and I'm just going to go through it quickly. Derivative of a square root, sorry about that, blurry, go away, is 1/2, inside stays the same, subtract 1/2, multiply by the derivative of the inside. And since the derivative of the inside was 2, these 2's cancel. So there's our derivative. F prime of 4, plug in 4. Square root of 9 is 3. And then this says find f of 4. So how do you find f of 4? We got to plug 4 back into the original. Oh, what do you notice? This is the setup for this, right? Write the equation of the tangent line of f of x when x is 4. Y minus y1, that came from here, equals the slope, came from the derivative, times x minus the x value. Same thing with g, but g is now cosine. The derivative of cosine is negative sine. Find pi over 6. Pi over 6 is the little itty bitty one, the first one. And the way that the coordinate points go, I count 1, 2, 3. So this is the square root of 3 over 2, and 1/2 is the y value. So this is asking for the negative sine of pi over 3. So you keep that negative in front. See that negative? Keep it in front. And the y value was 1/2. So the sine of pi over 6 is 1/2. So the slope of the tangent line is negative 1/2. Find g of pi over 6. Okay, g of pi, that's the original. So what's the cosine of pi over 6? Good thing I wrote this coordinate point, because it's right there. The x value, square root 3 over 2. Find the equation of the normal line. Oh, look at this typo. Look at this typo. I can't believe I did this last year. Okay, this is the tangent line, because that's the slope is negative 1/2. But do you remember what do you do with the normal line? The normal line, this is the slope of the tan shown. The slope of the normal line is perpendicular, so that would be the positive reciprocal. So the slope of that normal line is 2. I'm so glad I used that paper and found this mistake. What does part I say? Suppose that h equals g times f. You should just get used to this, okay? Is h increasing or decreasing at this value? Increasing or decreasing means is the derivative positive or negative? So what do we need to do? Product rule. fg prime plus gf prime. But it's backwards. I think since it's a sum, it would be the same, right? But I just did it following the rules. We have g times the derivative of f plus f times the derivative of g. G is cosine. The derivative of f we already found. That's nice. Plus f times the derivative of g. We already found that above. So use your answers from above. And now we get to plug in 3 pi over 2. 3 pi over 2 is 270 degrees, right? So that's straight down, and that coordinate point is 0, -1. Is that right? Hope so. Think so. We'll check it. Always check your work as you go. So everywhere we see x, we put in 3 pi over 2, everywhere. Cosine of 3 pi over 2, 0. All right. 3 pi over 2, when you plug it in here and you have 2 times, do you see how those 2's will cancel? We'll get 3 pi. That's good. Again, here the 2's cancel. We get 3 pi plus 1. And then the sine of 3 pi over 2 is -1, but we had the negative sign, so it's going to be -1. Sorry, let's go back to here. Cosine of this is 0, so this entire factor turns to 0, this whole thing, because it's 0 times this, so this is all 0. And then the square root of 3 pi plus 1 can't be simplified. A negative times a negative is a positive. So we have a positive square root 3 pi plus 1. I bet you've never seen that answer before. Okay, you tell me, is this positive or negative? Well, I don't know, there's no sign. Well, the square root will always be, is this positive in front? It will always be positive. So h prime of 3 pi over 2 is greater than 0, means h is increasing. This was a big math problem, but that's what AP is. This is the level of AP. It's not just going to be a simple take the derivative using the power rule. All right, a difficult derivative, a difficult plug-in, a difficult simplification, a trig. Yes, difficult, but you can do it. I believe in you. Here we go. Approximate the value of the derivative. The approximation of the value of the derivative, you guys, is the secant line, the slope of the secant line. So 2 is the slope of the surrounding points, the secant line, also known as the average rate of change. So you take the derivative, you take the slope, look at here, I have it boxed in red, y2 minus y1 over x2 minus x1, like that. Is that it? That's it. Will that be on the test? I don't think, not today, not this one, but we're going to do that a lot. It will be on the AP exam. It's super easy. It says find the derivative, but you weren't given a function. So if you're ever given a table and it says find the derivative, you just do your slope formula, y2 minus y1, x2 minus x1. Okay, what did I tell every class? You must take the derivative with respect to the x's before you plug in any values. I'm just going to show these answers. I only have 3 minutes left. So the derivative of b, we see this chain rule, multiply by the derivative of the inside. We need a slope, so we plug in 1. That's what we got. It's yucky, I know. That's okay, you can do it. You also need a y value of b, so it's not a y value of f or x or g, it's b, which means you have to plug it in to the square root of g of x, so g of 1 is 3, so the y value for the b function is the square root of 3. Here we have the tangent line. Y minus y1 equals the slope, which we got from here, times x minus x1. Okay, last but not least, part C. I kept thinking, should I shorten this in any way? All of this stuff is good stuff. Will this be on the test? You know what? I can't make a 3-hour test, but is it all from AP? Yes, it's all from the AP exam. So it's good for you. Okay? Here we go. Oh, come on. If A equals this product, this is a product times ln with something inside. What is the value of A prime of 2? So you ready? It's a product, so we use the product rule. F g prime. The derivative of the ln is u prime over u. So whatever was here, I put that down here, and I put u prime up here. Plus the second function times the derivative of the first. You must take the derivative with respect to x before plugging in the value. I've said that so many times, you better be ready for it. Once you plug in the value, we get our wonderful answer boxed in here. Now, is this positive or negative? It's positive. So what does that mean is happening here? Since it's positive, it's increasing when x equals 2. I hope that was a helpful explanation. It was super fast to do all 3. Each one should take about 15 to 20 minutes. So this is just a review. Hope that helps. Bye.